this assessment, we're asked to predict the product of the metathesis reaction shown. Now recall that the metathesis reaction is where we take some alkene, RCH attached to a CH2, and react it with some other alkene, we'll call R prime, CH, CH2, and simply stitch them together. So we'll take this carbon and this carbon, stitch them together to make a new, more substituted alkene, and this CH2 and this CH2 will also be linked together to make ethylene. As a metathesis reaction, we can think of it as this carbon is going to exchange its CH2 for this group here. This molecule exchange its CH2 for this group here. So we're just going to exchange partners. If we want to then predict the product of this reaction, I've gone ahead and starred the two carbons that are going to be connected. So the CH2 that's here and the CH2 that's here will react to make that ethylene molecule. The rest will just be connected. What remains, what's on the left side here and the left side here, will be connected. And so we can draw our product down here. We'll want to make sure we don't lose carbon, so we'll go down, up, down, up. This will get us to the starred carbon. We're going to have a double bond to the other starred carbon, and then up to our benzene ring. Most of the time in metathesis reactions, when we're making acyclic molecules, we're going to end up with the most stable transalkene. This is the product of our metathesis reaction.